What's up guys, Nitin here from Center Second, and today we have another banger of a video, 15 deceptively simple math problems most people cannot solve. So I literally just opened this up right after the circle video I just filmed, and if you have not watched that circle video, it's a very interesting video. It's almost a paradox, and I'll leave you to it to figure out why it's a paradox. So here it says sometimes math problems appear to be incredibly simple. That is until you actually begin to try to solve it, and then you realize you have no clue what you're doing and starting to question your own. So here I have my notes. Let's see. I haven't looked at these yet, but I'm very excited to do them along with you as well. So hopefully if you do get them all, let me know down in the comments. And if you like these type of videos, let me know down as well and like the video. Alright, so the first one, bat and ball. And the interesting thing about this is that there's 15 of them. Let's see if we can get through them quickly. So let's see. Alright, so I didn't want to see the answer, and then the answer is right below it. So it's a whole written response. But let's go to the first one. Bat and ball. This is a classic problem that has stumped almost everyone who has come across it. Hopefully it doesn't stump us. The question is that a bat and ball costs $1.10. So a bat and ball costs $1. So bat and ball costs $1.10. The bat costs $1 more than the ball. So bat plus $1 more than the ball. So that means you would have to actually subtract $1 from the bat to get the price of the ball. So the bat in this case is the expensive item. And so how much does the ball cost? So we know in total the whole thing is 110. So intuitively you would say that these two things on both sides have to be equal. So since I know that bat plus the ball is 110, I can say bat, let's see. Well, instead of doing like the logical format, let's just get through it quick. I would rather say that 105 minus 1 equals 5 cents. Because if something costs $1 more, and you know they both add to 110, one has to cost $1.05 and one has to cost 5 cents. And so when you minus on the left side, you get 5 cents on both sides. And so the ball in this case costs 5 cents. And so let's see. It says, we'll give you a second to think about it. You got your answer? Did you say 10 cents? Well, we didn't. And hopefully you didn't as well. And if so, you'd be wrong. The correct answer is 5 cents. Yep. So when you look at the problem, you know that your brain is going to say 10 cents because you're going to associate the dollar and then subtract it immediately and forget about the relationship between the two items. Well, that's a very interesting problem. Hopefully you got it right. Let's go on to the next one. And so 14, the lily pad. There's a patch of lily pads on a lake. Every day, the patch doubles in size. So every single day, every day doubles. Okay, interesting. Doubles. And what we see is that if it takes 48 days for the patch to cover the entire lake, how long would it take to cover half the lake? So 48 days, it takes the entire lake to be covered. Well, we have this relationship that doubles every day, so we would rather just subtract 1 day and have that 47th day where we have half the lake covered. That's the relationship that this follows. It's more of a doubling effect. And so you would say it's 24 because of the double. You would half it in your mind, but rather it's 47 like we did. So nice job, pat on the back if you did get it right. And so here we have number 13. So the thing about this, I don't even know where like the answer and the question start. So we're just gonna look at the question and say, all right, so 6 divided by 2 1 plus 2. These type of questions are always on the internet, just like causing people to argue all the time. I don't understand why people can't do simple math. Followpemdas is right there. They give it to you in the title. So you do the parentheses first. So you do 1 plus 2 is 3. And so you got 2 times 3, but you have the division first. And the way this works is that multiplication and division come together and you do them left to right. And so, but you do have that parenthesis you need to complete. So this parenthesis needs to complete it. So you have to do the actual multiplication. So you do 6 divided by 6, which is 1. So let's see if we did get it right. So chances are you saw this question around Facebook. This question has caused a great divide, as some believe the answer is 1, while others believe the answer is 9. The answer is, drumroll please, 9. Remember PEMDAS. Alright, so they got a 9. Let's see how they got that. They said the order, parentheses, exponents of PEMDAS. The reason this simple equation has confused is the way that people interpret PEMDAS. Just because a number touches the parentheses does not mean that it should be multiplied before the division to the left of it. So according to PEMDAS, you need to solve for what is inside the parentheses, then the exponent, then multiplication, then division. But most importantly, from left to right. As a result, you'll see that what they did first was, let's see, they did this, so we got this right. And then what they did was, so they divided the 6 and 2. They divided these first to get the 3, which I don't agree with. So does the parentheses just go away? So when you add, the parentheses just go away. Interesting. Alright, so I guess I got that one wrong. Hopefully you didn't get that question wrong. And we'll move on to the next one. So the Monty Hall problem, I've heard of this one before. It's the 3-door one. You pick one, the other one it's taken away. It gives you another choice. So let's see what happens. So it's a very long. So where does the question answer or whatever? Let's pretend you're on a game show and the host gives you a choice of 3 doors to choose from. Behind one door is a brand new car, and behind the other 2 doors is nothing. So we have 3 doors here. So 2 X's and a car in the middle. So let's say, okay, so it says, let's say you pick door 1 since the host knows which door the car is behind, and decides to open another door. So we basically choose this one, and he closes another door. So let's say he says this one is out now. So we have the first 2 doors still available. So, and decides to open another door. He opens door 2. So let's get rid of this X and say, so in our example, we could just leave the X there, whatever, and shows that there's nothing behind it. But then the host gives you a new option. You can stick with your original choice or switch doors. The question is, do you stick with your original choice or change your mind? So what would we do? So let's say in our scenario, I don't know what I chose. So in our scenario, if we switch, we would win. And if we left it B, we wouldn't win. But we don't know what's behind it. Now in our example, we can see what's going on. But let's look at it mathematically. So what we see is that originally each one had 1/3 chance of being picked. Now once you get rid of that option, is actually both of these, you get the option of having a higher percentage on your door. So what that means is that since this goes away, these 2 are left, and they give you the option to switch. And so it heavily favors my door. And so I believe, without me even like knowing, so since we know that my box doesn't have it, you would still keep the door that you have. Because I believe you would have a 2 out of 3 chance instead of winning. So let's see what the answer key would say. So it says, do you stick with your original choice or change your mind? Well, you might think that there are only 2 doors. Well, you might think you have 50-50 chance of winning the car because there are only 2 doors left. You'd be sadly mistaken. you should always switch. You initially had 1 in 3 chance of picking the prize winning door. Yep, so 1 in 3, since in our example is in the middle, and which means you had a 2 in 3 chance of picking a door with nothing behind it. So when the host reveals an empty door and eliminates a wrong choice, the chance of that car behind the last door is 2 out of 3, which is twice as great as the odds that you picked on the right door on your first try. By switching, you are betting on the 2 in 3 chance that you picked the wrong door on your first try. So in our case, so I technically got the question wrong because what they're saying is that, so initially I had a 1 in 3 chance because there were 3 doors. And then you had a 2 in 3 chance of picking a door with nothing behind it. So when you get rid of one of them, that means you actually have a 2 out of 3 chance of getting it if you switch. So you're getting another lifeline basically. So you would always switch. And even in our example, we should have switched. And that's kind of obvious now when I think about it, because there's certain kind of pressure when you do these type of questions in a video or in during a game show or something. A certain type of pressure that your mind just goes in a fog, and then you don't realize that it doesn't really mean much. It's just a game, right? So what happens? I just realized is that if they get rid of this door, the third one, they can't reveal the second one because it has the car. They can't reveal the first one because I picked it. So they have to reveal the one there's nothing in there. So you have to switch. It's like almost like they're like giving you the prize if you're gonna switch, because they know that they can't show yours because the game's over then. They can't do the Monty Hall problem. That's a very interesting scenario. There's pretty more combination than this problem, but very interesting. So I don't believe I think we'll do 2 more. I don't want to take up too much of your time, but if you did enjoy this video, let me know down in the comments. We can maybe finish all of these puzzles, but let's go. So the number puzzle, we got 915 483 2 blank 7. So someone need a little mental break. Don't worry, this one shouldn't be too difficult to solve. Then again, that can be said about most of these problems. This type of number puzzle is meant to improve your logical thinking. There are specific rules for types of number puzzles. You first have to figure out the pattern that the puzzle follows. Then you have to so you have to figure out the pattern, then you have to answer the puzzle according to the established pattern. With all that being said, looking at the picture above, can you see question mark is supposed to be? Alright, so right now we got a 915 483 2 blank 7, and so there are connecting features as well. So I'm trying to think, do the connecting features actually mean anything? Let's see. So they're all circles. There's nothing going here. We do see that 1, 2, 3, 4, 5. There's no 6. So what I'm thinking is that this could be a 6 if they're but that wouldn't really make sense because this is a logical problem, and I don't really think they would just give you like, okay, you just need a 6 here. I'm thinking it could be something a little bit more difficult. So let's see. So maybe it's a magic square or something. So let's see. Let's do a box around or a circle around all of them. Do the connecting lines, and let's see what's going on here. So we have this as well. All right. So let's try to add, and let's see what we add. 2. So we get 2 plus 4 plus 9. And that equals 15. So this one equals 15. We can see equals 15 as well. And this equals 15 as well. How about this square in the diagonal square thing? Let's see what that equals. So 4 plus 1 plus 3 is 8. 8. And there's an 8 in the middle. Does that even get involved? Well, we know that this square here equals the 8. And maybe that preludes that the 8 in the middle equals the 8 side of the diagonal square. But we do have this thing here, 2, 7, and a blank. So a 9 plus a blank equals 15. Well, the blank here would just fill in and be the 6. Because 9 plus 6 is 15. So we did all of that for no reason. Or are we overthinking this? Very interesting here. Very, very interesting. Well, I'm just gonna stick with my gut and just say, all right, it's 6 then. We solved it. We said that the 6 here in the middle needs to be, it forms a perfect square with 15s on each side, but let's see. So did you guess 6? You would be right. According to the pattern, the numbers in each row and column add up to 15. So I'm guessing this square in the middle, well, this equals what? 4 plus, that's 5 plus, what? That's 14 in the middle. That's very confusing. That the square, the diagonal square, the one that's red and blue right now, equals 14. That kind of threw me off, but I guess, very interesting question. So last one, because we're already 16 minutes into the video and don't want to take too much of your time. But you have one, so this is fast addition. So you have 1,000. You add 40. All right, so 1,040. You add another 1,000. You got 2,040. You add a 30. You got 2,070. You add another 1,000. You get 3,070. You add a 20. You get 3,090. And you add another 1,000. You get 4,090. Now add a 10. You get a 4,100. So I'm guessing what would happen here is that you would get like a 5,000 something if you, because if we did it together, and if you did it by yourself, maybe it almost plays a trick on your mind that you might write 5,000. Oh wow, that's exactly what they're saying. Wow. For the next problem, don't use a calculator or paper. Try to solve it. What do you get when you add all these numbers up? Did you get 5,000? Sorry to say that's wrong, but the correct answer is 4,100. Very interesting how your mind plays a trick on you. It's almost like that 20 we added caused the 90 to almost act like a 900 because they're dealing with thousands, but the tens place is being adjusted. So it's like, are we increasing the 4 because the 9 goes up and you got to carry it now? Or that's very interesting. So if you got it wrong, don't feel bad. A lot of us do. Your brain was just getting ahead of itself. You're probably doing great until the last number, which is very true. We were doing very great up to here. I had to take a second to pause and was like, what's going on? I've already got, I think, a few wrong. I don't want to keep getting them wrong, but yep. The thing is that you're adding everything up and you didn't use to carry any of the ones over, and then when you get the final number, you accidentally add it to the thousands instead of the hundreds. Wow. That really played a trick on my mind. If it did, let me know down in the comments. Hope you enjoyed. If you want me to do the rest of these questions, let me know down in the comments. I had a blast. I don't agree with the PEMDAS one though, but we can settle that dispute in the comments. But thank you so much for watching. If you need any tutoring help, all my information is down in the description. I only charge a cent a second. But other than that, peace out.